Question: An airplane maintains a velocity of 630 kilometers per hour. Direction is north relative to the air. As it makes a trip to a city 750 kilometers away to the north. A. How long will the trip take when the wind velocity is 35 kilometers per hour? Direction south. B. How long will the same trip take when there is a tailwind of 35 kilometers per hour? Direction north. Instead, why does the answer change? C. What will the pilot do if the wind velocity is 35 kilometers per hour? Direction east. Instead, how long will the trip take in this case? We use P to represent the airplane and use A to represent the air and use E to represent the earth. So the airplane is here, and here is the city. The city is to the north of the airplane. Here is airplane. Here is the city. And this direction is north. The distance between the airplane and the city is 750 kilometers. And the velocity of the airplane relative to the air is 630 kilometers per hour. Direction is north. And we also know the displacement of the airplane relative to the earth is 750 kilometers, and its direction is north because the airplane flies to the north, flies to the city. This is the direction of the displacement. And A, it says the wind velocity. The wind is just the air, so the velocity of the air relative to the earth is 35 kilometers per hour, and the direction is south. And this equals negative 35 kilometers per hour, direction north. So here it's positive, but the direction is south. Here it's negative, but the direction is north. Now, the velocity of the airplane relative to the earth equals the velocity of the airplane relative to the air plus the velocity of the air relative to the earth. Now this equals 630 plus negative 35, and this equals 595 kilometers per hour, direction north. Now the time interval just equals its displacement divided by its velocity. Now this equals 750 divided by 595 and equals 1.26 hours. Now question B. Question B, the velocity of the air relative to the earth equals 35 kilometers per hour, direction north. Then the velocity of the airplane relative to the earth equals velocity of the airplane relative to the air plus velocity of the air relative to the earth equals 630. Now it's plus 35 equals 665 kilometers per hour, direction north. And the time interval equals its displacement divided by its velocity equals 750 divided by 665 equals 1.13 hours. Now question C. Question C. The velocity of the air relative to the Earth equals 35 kilometers per hour and its direction is east. And we know the velocity of the plane relative to the Earth equals the velocity of the airplane relative to the air plus the velocity of the air relative to the Earth. We know the relationship. Now I draw the graph. This is the velocity of the airplane relative to the Earth. Its direction is north because the plane need to fly to north to the city. So north is the direction of the velocity of the airplane relative to the Earth. And this vector is the velocity of the air relative to the Earth. Its direction is east. Now, this vector is just the velocity of the plane relative to the air. Because we know the velocity of the air relative to the Earth plus the velocity of the airplane relative to the air equals the velocity of the plane relative to the Earth. So this graph shows the relationship, and this is a right angle. And we set this angle as theta. And from the graph, we can know that the magnitude of the velocity of the plane relative to the Earth equals square root the magnitude of the velocity of the plane relative to the air square minus the magnitude of the velocity of the air relative to the Earth square, and equals square root 630 square minus 35 square, and this equals 629.03 kilometers per hour. And now we know the velocity of the airplane relative to the Earth just equals magnitude 629.03 kilometers per hour. Its direction is north. And now the time interval just equals its displacement divided by its velocity, and equals 750 divided by 629.03 kilometers per hour. This equals 1.19 hours. And let's go back. The question B asks, why does the answer change? The answer change is because the velocities are vectors, and the direction of the wind velocity changes. Its changing causes the change of the velocity of the plane relative to the Earth. Because the velocity of the airplane relative to the Earth changes, then the answer changes.